Welcome to Speaking Concretely, the official podcast of the Cement Association of Canada. I'm your host, Adam Auer, President and CEO of the CAC. Today on our podcast, we're joined by Kael Opie, a principal at KPMB Architects. Kael brings expertise in advanced building technologies and experience integrating energy efficiency and cutting-edge sustainable strategies into building design. Kael was project architect on the first LEED Platinum certified commercial project in the Toronto area, the Elementary Teachers Federation of Ontario building, and on Manitoba Hydro Place in Winnipeg, one of my favorite buildings and one of the most energy efficient towers in the world. Kael, thanks for joining us today.
Thanks very much for having me, Adam.
Why don't we start with a little bit more about you? Tell us a bit about yourself and your experience. And, I note that you've worked on some of Canada's most energy efficient buildings, from the Manitoba Hydro Place and the first LEED Platinum commercial project in Toronto that I mentioned in the intro. So maybe you could also tell us what, has drawn you to sustainable building design specifically.
Sure. So a little bit about me. I've been in the industry for about 30 years, and I've had the privilege to work with some really outstanding design first firms, both as an employee, but also as joint ventures with on a number of large projects. And I've had some really inspiring mentors that have helped to kind of shape and color and provide a lot of perspective on the profession for myself. And I've been with KPMB for just over 20 years now, and very proud of the work we've been able to produce together as an office. My very first project was actually the Manitoba Hydro office tower. And I've gone on to work very closely with Bruce Kuwabara on almost every project I've worked on here in the office, as well as Shirley Bloomberg and Marianne McKenna. And then also working really closely with a couple of other partners, Luigi LaRocca and Mitchell Hall. And I think it's safe to say that we all have a very kind of shared opinion on the importance of sustainability in particular. And all of this work collectively has had a real influence on how I see the profession and I guess also how I see our role as architects. I think right from the very beginning, I've had a very, we'll say, healthy fascination with how buildings come together, how materials work, how building systems work. And I think it's at that intersection where all of these elements come together that's where I found a lot of enjoyment and satisfaction. That's my kind of happy place within the profession. That's where I think there's so much opportunity and for development and growth, and I always focus on a lot when I'm working on a project. I mean, there's an immense amount of stuff that goes into buildings, and where we are right now collectively, I mean, relative to the climate crisis, both as a profession and as a society, we all need to be a lot more conscientious of what we're doing with the finite resources that we have available to us.
I'm going to put, some, I guess, practical details on some of those comments through some of the questions that we get into in a minute, which I'm really excited to dig into. But KPMB in and of itself is also quite unique in the sense that I understand you have an internal lab, an internal research group that I'm guessing is driving a lot of how you approach, some of these questions you mentioned around sustainability and building innovation. What's the mandate of that lab, and how does it play into, in very practical terms, the stuff that you're actually implementing on a project scale?
Sure. I mean, I guess the role the lab has played in the office has shifted a little bit over time. It was started about 8 years ago, and it was originally focused more on pure research and I think trying to find strategies to better understand how architects and the industry could better communicate with one another and to understand what could be done around the climate crisis in particular. I think over time, this has slowly shifted, the mandate in the office has slowly shifted to become something that's more pragmatic and broader in its approach. I mean, the focus has always been on sustainability in its kind of most common meaning today, but we feel it's really important to understand sustainability in the broadest sense. We need to think about social sustainability. How will people interact with the built environment, and what kind of positive impacts can we have beyond the immediate building brief? Need to think about economic sustainability. We always need to make sure that the building that we design is economically viable, but we also need to be thinking about the future of that building. What might that building be doing 50, 60, 100 years from now down the road? Is that building going to last? How's it going to be serviced and updated? Might it serve another purpose in the future? These are all things that we need to be thinking about in the present when we're designing. So in lab, we make sure to engage every team in every project in the office to talk about what might be possible and look for opportunities, even when, or often, especially when a client hasn't stated a specific metric or a goal for the project. We've developed over the last few years a huge range of simulation tools and workflows to help our teams understand and optimize projects. And that can include early microclimate analysis for outdoor spaces, early stage embodied carbon analysis, building facade and radiant solar gain studies. There's a long, long list of tools that we have available to us. But common to all of these studies is timing. It's critical that we get in early, we set goals, we have the discussion with the client, we get client engagement and understand all the gibbons around a project site, exposure, climate, existing conditions. If a design is already in play before we can have those discussions, it's often too late. And the opportunities that are available to us become substantially reduced. So timing is critical. And over the last few years, we've become much more engaged in industry research groups and initiatives, groups like the Toronto Bibuild Collective and the Carbon Leadership Forum. And that's been hugely satisfying for myself personally. And I know a lot of people in the office feel the same way, to be able to bring people in to speak to the office, to kind of find like-minded individuals in the industry for support and sharing resources. It's been a huge help. It's reassuring to know that we're not alone in this, and that we have an opportunity to share a lot of resources with other offices and make a collective, really positive change within our little corner of the country.
Well, there's a lot to unpack there. It sounds like you take a very sort of broad and kind of comprehensive approach to even thinking about what the sustainability challenge looks like in the broadest terms when taking on projects. But let's talk about it at a project level and what it actually means. And I think I've got two sort of projects of yours that I want to talk about that I think kind of anchor a lot of the challenges and opportunities that you were alluding to there. And one is about 20 plus years old now. And the second one I want to talk about is a little bit more contemporary. So maybe you could even talk a little bit about what's changed in that period of time. But the first one, as I mentioned in the intro, is Manitoba Hydro Place in Winnipeg, which is a beautiful concrete building, 80% more efficient than conventional buildings in Winnipeg. And it was the first large-scale office tower in North America to be LEED Platinum certified. I've personally toured this building a number of years ago, and it really is a marvel of clever design, which goes far beyond just changes at the material scale to really sort of thoughtful design elements that feed into the overall sustainability and resilience of the project. Maybe you can walk us through this project a little bit, and in particular, how the design of the building is so core to achieving its impressive performance.
I think what Manitoba Hydro Place really did for me was it opened my eyes to what was possible. I think what was accomplished was all due to the team that was built and the vision and the leadership of the client group. And I think the engine behind all of this was the integrated design process, or maybe what's more commonly described these days as IDP. So what is IDP? Essentially, it's a process by which the collective team, and I'm including the client in that team, has equal presence in the design process. So everyone is in the room together. Everyone has a say in the design solution. It's a workshop-driven process. And in simple terms, this is kind of like to think of this as the inversion of the traditional model, where the architect develops the concept, takes it to the engineers and says, figure out how to make this work. So really you're in the room together. All of these key design decisions are made with the client and the engineer involved in the conversation. So I think what was also really unique about Hydro is they set out in the beginning, part of the mandate was a 60% reduction in operational energy relative to the MNECB, the Model National Energy Code building, which at the time was something that hadn't really ever been done at the scale of an office tower. And there was a lot of uncertainty and questions about, can we do this? Is this possible? So the client set out to collect the design team individually. I mean, I think they really went and looked for the kind of leaders in each of their field. So this was our first introduction to TransSolar, company based in Stuttgart, but also has offices in New York. And we've gone on to work with multiple projects with TransSolar since then. And when we were introduced to TransSolar, they were brought in to serve as the climate engineer. And I recall thinking, what is a climate engineer? Ultimately, TransSolar brought a lot of unconventional thinking to the table, and an ability to apply passive systems, or I guess what you could also just say, quote unquote physics, in a clear and unencumbered way. And I have to give a huge amount of credit to the engineering team and the client who approached all of this with a very open mind. This is a building that is conditioned with 100% fresh air 100% of the time, regardless of the season. And for large portions of that spring and fall seasons, it uses no mechanical ventilation systems at all. So we're talking about a climate that goes from 40 degrees below Celsius to 40 degrees above Celsius. Huge swings in temperature and humidity over the course of the year. So the solar chimney at the north side of the building creates a negative draw that pulls air through automated vents at the south window garden and across the double facade, depending on the season, to ventilate all the office floors. And at every glass face in the building, there's an automated horizontal blind with a very deep blade. And depending on a set of real-time climatic inputs that are collected at a series of weather stations attached to the building, this adjusts to either reject or absorb solar gains into the building. And then there's also a large geo-exchange field below the building, which has become quite commonplace now, but at the time it was the largest in the country. I think what's really interesting, though, at the end of the day is this is a very lean and simple building. And once you understand how it all works together, it's pretty simple. That can be, when you're talking about passive systems and natural ventilation, it can all seem very complex. And there is a lot that goes into designing a naturally ventilated building, but the principles are all very clear. And I credit that open and collaborative and rigorous integrated design process with getting us to that place. There's a simple set of questions we kept asking ourselves, like, how does it work? Does it work well? And can we simplify it? And is there a better way to do this? And in the end, through a very intensive process, we ended up with a very simple building, and a lot of the kind of unnecessary elements were rinsed away in the design process. So I think that's proven in the ongoing performance of the building, which has always managed to meet or better its original 60% reduction mandate. I think the building has been operating at a 75 to 78% better than Model National Energy Code since it was commissioned.
I mean, one of the things we love about that building, of course, is that it's a concrete building, but also that the material itself plays a role in that natural ventilation, heating and cooling strategy because of its thermal mass. And I remember I was director of sustainability here at the Cement Association back when I toured that building over a decade ago now, that operational energy and operational efficiency was still sort of the dominant conversation when it came to the sustainability of structures. And of course, we were, very interested in showcasing how, concrete could be used to achieve high levels of operational efficiency. Conversation has obviously shifted dramatically since that time. Operational efficiency is still clearly very important, but there's a lot more focus on the embodied carbon or the sustainability impacts of the materials that we're using to build these structures in the first place. And this is why I thought it would be nice to contrast that Manitoba Hydro Place project with a more recent project that you partnered on with University of Toronto, Queen's University, Arup, Aecon, Lafarge, which is now known as Amrise in North America, on the demonstration pavilion for Kingston's Fire and Rescue Training Campus that cut embodied carbon by 86% without really inventing any new materials or any sort of commercial ready kind of technology approaches. Why don't you walk us through that project as kind of a modern expression of what sustainability looks like in the built environment today?
Yeah, thanks, Adam. I am really, as you mentioned, the conversation has shifted dramatically. Like it's just in the past 20 years, it's really heartening to me to think that nobody even had embodied carbon on their radar at that point in time. We were talking entirely about operational carbon and not even operational carbon, just energy consumption. And I think as an industry, we've gotten very, very good at delivering consistent energy efficiency in our buildings. So I think now the focus has shifted to carbon, and I'm very optimistic that the industry will continue to respond. And I think we have the additional pressure of the climate crisis to motivate us. But I think the industry as a whole has really shifted entirely towards looking at embodied carbon. I mean, the Queen's project was a fascinating little project, and we were approached by Queen's University engineering professor Neil Holt and U of T engineering professor Evan Bentz about getting involved in this small training space for the city of Kingston's fire and rescue department. This was essentially, it was a tiny little standalone classroom at their field facility. And the city had already completed a very low energy training center on the site. And they approached the university to see if they could help to create a project that was site net zero and with lower embodied carbon and would be simple to operate and cheap to operate. But they also wanted something that would be a long-term resilient building. So Dr. Benson Holt had been doing a lot of research with their grad students on novel concrete shapes and lower embodied carbon in concrete. So when we first started to talk about how we might approach these kind of novel shapes were a really logical and obvious direction for us to investigate. And we also reached out to get some industry support in the form of MEP in structural engineering from Arup, and AECOM served as the CM for the project. And as you mentioned, I guess at the time, Lafarge, who was known as Lafarge, was also involved in providing some input on locally available SCMs and lowered carbon mix options in the Kingston area. So we started at the most logical place, which was to reduce the amount of concrete that we were going to be using in the building. So applying these novel shapes, coming up with some really interesting forms and ideas, and we were ultimately able to reduce the concrete volume by roughly 40%. The complexity of pouring these kind of novel shapes was challenging in the lab, but out in the field, it was really problematic. And the other issue we faced was the cure time of the concrete. Like, we could reduce the amount of concrete in the building by roughly 4%. And then what we could do is apply a very low mix concrete to that reduced concrete volume. We looked first at a very aggressive mix that would get our carbon down by about 60 or 70%. But the problem is that these lower carbon mixes sometimes require a much longer cure time. And leaving the forms and the reshores for those pours in place for that longer cure time meant it had a real fundamental impact on the schedule of the project. So without incurring a logistically challenging cure time, which would drive the schedule and increase costs and add a lot of complexity to the project, we we were able to secure a carbon reduction of about 30% using a common SEM that was already widely available in the Kingston area. And with the shape optimization, we were able to get our total carbon reduction up to about 55% of a standard or kind of business as usual mixed design. That was pretty good, but we immediately wondered if there was more that we could do.
So, I mean, what you're describing is actually something that's come up on a number of our podcast discussions about some of the challenges of using lower carbon mixed designs. In particular, if you've got a high proportion of supplementary cementitious materials, you get delayed cure times, which are often really the driver of cost increases when it comes to more sustainable buildings. It's not the cost of the materials per se. It's more about the costs of having to extend the schedule of different projects. And we've talked with, some other architects and construction professionals about, various strategies for overcoming those challenges, being selective about where you use different types of mixed designs. But it sounds to me like you guys were really trying to push the envelope. You found, up to 30% reduction with a supplementary cementitious or mixed design based strategy. You found another 26% or so through material optimization, by being creative with the types of shapes and design you were using on the project. But ultimately you ended up with 86% reduction. Clearly the ambition to go further was already there, but with the challenges that you described, what was it that drove you to reach for those higher numbers, and how did you ultimately achieve them?
Right. I mean, I think ultimately we're looking for a solution that was repeatable and scalable. And this kind of novel shape design process coupled with a moderate carbon reduction of about 30% got us to about a 55% reduction in carbon on the project. But we weren't really happy with that. We wanted to see if there was more that we could do. And, I think we were really hoping that this project would serve as a benchmark or a case study to show others what could be possible. So we went back to the drawing board and started to talk to our industry partners and about how we might move around this issue. And is there more that we could do? And struck upon the idea of using precast elements instead of cast in place.
And the precast strategy was driven largely by a desire for replicability, but how did it help you with with achieving those higher embodied carbon reductions?
Moving to precast meant that we could pour these complex forms in a warm, dry shop with a lot more quality control than we could ever achieve consistently in the field. So we have a consistent set of conditions that could be easily repeatable. We have a lot more control over how the mix was applied to the form. And then secondly, the reshore or the cure time in a precast situation meant that we could ostensibly remove the cure period from the construction equation. And the cure times for the precast elements would be longer than conventional precast, but it would allow a much more aggressive carbon reduction mix. And because these forms were curing in the shop, there was no longer a critical path issue on site. That meant that that allowed us to use a much more aggressive carbon reduction mix. And the third item, which was really attractive to us, is we could dramatically lower the construction time and the carbon emissions on site. The precast elements could essentially be bolted together on site. It means the time on site for the CM, for the field crews, was dramatically reduced, and we could also reduce the amount of emissions on site from the construction process. And as an architect, we had a lot more consistency and quality in the texture and the kind of final form and texture of the concrete that was used on the building.
I hope some of our government officials are listening, because we've been advocating for the role of, modular precast systems in the larger conversation around affordable housing and speed of construction, et cetera. So it's, great to be able to highlight, an example of how that's been used and how it's been used also to achieve, class leading sustainability at the same time. And it draws me back to something that you said in your sort of introductory remarks about, well, and in talking about the projects, about the role of collaboration across, different decision makers in the construction value chain and early engagement and integrated design processes. Maybe you could help, me, our listeners, understand a little bit, what happens when those players are left out of the process, or maybe, I can ask more directly, who actually decides, what building materials are used on a project and what, ambitions or targets are set for, carbon or other performance metrics. Is it the owner? Is it the engineer? Is it the architect? Walk us through how that decision gets made and who needs to be at the table to make that decision durable through the design and construction process.
I think when we're talking about the Kingston project, I mean, we got Toronto Precast for Modular involved, and they brought to the table an Italian company called Structurama, and it was through that process that we were able to refine the forms and the shapes and the connection details to streamline the process. I mean, that is something that we would never have been able to come to on our own. And it's that integrated process that ultimately led us to a solution that I think none of us really envisioned when we first started the project. So we ended up in a very different place, but we were able to kind of exceed the original aspirations of the project just by looking at things a little bit differently and through that industry involvement. I mean, ultimately we were able to develop a small kit of precast elements, and through some careful design thinking, we were able to create elements that would actually have a consistent cross section. And then, this idea of the precast elements and a series of bulkheads meant the forms could be adjusted for length. So ultimately, I think the entire building boiled down to kind of 12 unique pieces. I think the other interesting thing about this is that we ended up with a system that was repeatable and scalable, which is not what we intended to start with, but this was a system that could be applied in multiple applications, or to grow the size of the system or to roll out a series of similar buildings. Again, not really what we set out to do, but was an interesting outcome of the process. And I think it is as much about process, or maybe more about process, than it is about the decisions that get made along the way. You kind of have to give yourself over to the process when you're trying to do something innovative. I mean, I think something that we really lean on heavily in our work is what we call a project charter. And at the beginning of any new project, one of the first things we often do is sit down with the entire team, and that includes the engineers and the constructor and the client, specifically the client, talk about what is going to drive the project, what's important to you, the client, and what ultimately does success on this project look like. And once these primary goals are set, the path forward becomes a whole lot more clear. Project delivery is an incredibly complicated process, and there are about 1 million different competing interests at any given time, but the project charter can serve as a kind of North Star on a project. And at any given time during the course of the project, any decision could be kind of tested and vetted against those charter goals. So I think as a philosophy, as an approach, it's critical that you have everybody that's involved in the process on the same wavelength, that everybody's kind of supporting the same ultimate goal or series of goals. You have to remain open-minded. Don't assume that what is the right, what you've always done is the right approach. Have to stay open-minded and think about kind of ultimately what's the goal of the project? What are we trying to do here? And in my experience, that makes all the decisions a whole lot more simple.
So you're basically saying that you need everyone kind of rowing in the same direction from the beginning of the process.
Absolutely. And everyone has to keep an open mind too. They can't, experience is incredibly valuable, but be willing to kind of move laterally and think a little bit differently than you have in the past. Don't assume that what you've always done is the right answer.
So the projects that this particular project on, with such a focus on embodied carbon is, I would say, still fairly unique, even among construction organizations and architectural houses that are committed to the embodied carbon conversation. Certainly from a material producer's perspective that has an interest in helping transition our industry to net zero, we still see a lot of resistance, or even if not resistance, maybe the ambition isn't as widespread across the industry as we might hope. And I think part of it comes down to something I think you've pointed out in the past, that even when carbon accounting is considered, it often happens late in the project instead of upfront, when you've got lots of opportunities for decision making around design and material selection, etc. What do you think is the solution to that? What would it take for the kind of embodied carbon consideration that you put into this project to be replicated in other projects and really taken seriously as a core metric alongside the traditional metrics of cost and schedule, etc.?
Yeah, I think it requires a change in mindset, and one that, and I may be unpopular with my colleagues for saying this when we're talking about choosing materials, and I think architects forget, in dealing with the kind of day-to-day project management and project minutia and delivering a very complex building, how much agency they actually have in determining the outcome of the project. And, I would love to see clients include a kind of carbon ceiling or a carbon allowance in their briefs. And, we are starting to see this with certain municipalities. Certain clients are starting to mandate this within their project briefs. So I suggest, we lean into this, and the market will respond. If there's a demand, the market will impart change.
Outside of I guess, embedding that the interest or ambition or commitment around embodied carbon, what do you see other obstacles to moving towards lower carbon materials? We've talked on this podcast a number of times, for example, about specifications, codes and standards, how often they stand in the way of some of the innovations that the industry is producing when it comes to sustainability. And I believe you've also argued for shifting from kind of a prescriptive approach to specifying materials to one that focuses more on performance, allowing the producers to work with the others working on the project to achieve to optimize goals, be it carbon or early strength gain or other performance metrics. What do you think is holding in particular public procurement back from making that shift away from prescriptive to performance?
I think the biggest challenge is uncertainty. And this is an industry in which risk is a dirty word and something that should be avoided at all costs. So, there's an apprehension, and it's completely understandable. And I think when we see with both architects and clients, and, for example, you mentioned performance-based specs, the idea of moving away from maybe more conventional product specifications, pure product specifications, towards a more performance-based set of criteria. There's a concern that it's going to limit the number of available options, or it's going to drive up costs, or it's going to isolate a kind of sole source supplier. And this can all be true if the specification is not properly constructed and considered. And I think setting embodied carbon limits within specifications, just like we set performance specifications for something like curtain wall or for concrete. This is not a radical idea. The performance-based specifications been around for a long, long time. It's just they tend to not be applied to conventionally sourced materials or specific materials. So, I think we're already seeing this happen within the construction industry for concrete, setting embodied carbon limits for some key materials, concrete or envelope systems, something that we've been doing for quite some time. It does require that architects and spec writers do the research and assure themselves that there are a number of viable options available on the market. One thing that we have had great success with is bringing alternative prices to tenders. So going with kind of conventional solutions and then bringing in an alternate performance specification option to the table and asking for separate prices. So if there's a competitive market and if a supplier is competing against a quote unquote conventional item, there's a lot more motivation to be cost neutral.
Given your experience trying to deploy these strategies in your projects, what's your view on sort of the low hanging fruit? We would argue that there's a lot of carbon emissions, just waiting to be reduced if the incentives are there and the ambition is there to do it. You've deployed a number of different strategies in the projects that we've discussed. From material efficiency to optimized mix designs. What do you see as the most promising in terms of near-term gains? Given the challenges around specifications and perceived risks associated with any kind of change in the construction industry. Is it improvements in cement as a material or concrete as a material? Is it innovation in structural design, or is there some kind of perfect balance between those two things that we could deploy immediately for significant carbon gains?
Well, I think in the industry we've seen on several projects that there is really no discernible cost increase if we are looking for carbon reductions in the kind of 20 to 30% area. Like that's an easy win, and it's something that it doesn't have a really functional. It doesn't make a functional difference in the design or the execution of the building. It's merely changing. And a structural engineer may challenge me on this, but I think from my perspective, it's a simple thing that an architect can work with a structural engineer to provide options for at tender and provide options for the client that they can choose from. But I don't think it's not just about speccing low carbon concrete. I think as architects and designers, engineers, we need to be more careful about how we design. Don't design unnecessary transfers. Don't design unnecessary concrete cantilevers. Like, be really judicious when you're setting out structural bays and slabs. Think about the volume of the material you're using, and there's often a more efficient application of the material. So think about what's going into the building. How heavy is the building? What are we putting into the building? And is there a better solution? And I think this applies to all building materials. And I'm not just going to pick on concrete, but we need to be more considerate of what we're using in all aspects of building and how we apply it to the final design of the building.
How about, material substitution? I feel like I need to ask this question because there is a subset of architects, certainly that we encounter, that is very fixated on material substitution as a solution for embodied carbon, in particular mass timber, but not exclusively. There's other building systems as well. But you've noted, and others have noted, sort of on the other side, that really there is no clear substitute at the kind of scale that we're talking about in terms of just the volume of demand for concrete as a material and sort of the essential functions that it performs in a lot of building designs. How do you see that playing out in the sort of broader community of architects? Do you see concrete's role in construction changing in any kind of substantive way, or is this an evolution towards the sort of net zero or fully decarbonized goal that the industry has set for itself?
I think the Cement Association has done a lot of really great work over the last few years in reducing carbon, and there are some ambitious goals that are being set. And fully supportive of that. I mean, concrete is so intrinsic and it's so ingrained in what we do. I don't see concrete going anywhere in the next, in the next 100 years. There are so many things that concrete does better than any other material. And we just need to be more considerate about how we use it. I mean, mass timber has seen a tremendous growth in the last 10 to 15 years, but there's simply not enough mass timber to scale that across an entire industry to realize the kind of carbon reductions that we need to target. And again, concrete plays such a unique and fundamental role within building that it's not going to be possible to replace, and that I don't think it's necessary to replace it. We just need to be more considerate in how we use it and how it gets applied, how we specify it. Hoping as technology increases and new solutions are tested, that we'll see other SCMs come to market that give us more latitude as designers and give us more opportunities to reduce carbon collectively.
So maybe to extend that into a final thought for the podcast, if you could change one thing, a code requirement, a procurement rule, something that the industry is doing on the manufacturing side, in order to accelerate us towards that low carbon necessity that we have to achieve in the built environment, and to accelerate the uptake of low carbon concrete, what would be the single most impactful thing in your view?
I think we are seeing this within certain municipalities, and I think ultimately a kind of carbon performance requirement, just like we have a model national energy code requirement that we have to meet certain energy efficiency requirements. I think taking that same strategy and approach with embodied carbon is the right way to proceed. And I think there might be an argument of when that happens, and there are a lot of different ideas about how to implement it, but ultimately I think limiting the carbon footprint of a building is the right way forward, and ultimately will drive the kind of industry change that we need to see happen.
Aligns perfectly with our view, actually, as we've been negotiating. We actually worked very hard with the Treasury Board, Secretariat of Canada, to establish an embodied carbon standard for concrete used in federal projects. And we're now advocating quite strongly that other levels of government, and especially municipalities, adopt it into their own procurement practices. So thanks for supporting that goal. Kael, very nice to chat with you today. Thanks so much for taking the time to speak on our podcast.
It's been a pleasure, Adam. Thank you very much for having me.
Thank you to our audience for listening. And don't forget to subscribe and follow our podcast on your favorite platform. We hope to see you next time.